Hello everyone, welcome to this video. So, in this video I will be doing 2020 June CSIR question papers. I will be doing the next 5 questions, that is question number 22, 23, 24, 25 and 26, right. So, as you know, I will be doing only organic questions. So, let us start. The first question says the major product A and B formed in the following transformations are. So, what you are seeing is your reactant is pretty much same in both the reactions shown, and the reagent is absolutely the base used is sodium hydride, which is a very powerful base. Only difference is in the first reaction which gives the product A, you have NH2 at one end, other one you have SH minus. So, now NaH is a base. So, what will base do? Base will pick up the most acidic proton. So, very clearly proton on nitrogen, proton on sulfur is acidic, because if you remove them, the conjugate base form is stabilized, because nitrogen electronegative and sulfur is quite large in size and can stabilize the negative charge. So, let us look at the first one. You get this. Now, what you have to understand is nitrogen is very small in size compared to sulfur. So, this one negative charge is highly localized, and so it is more of a charge interaction than nucleophilic attack. So, this has huge amount of negative charge, and so it will go and attack that position which has huge amount of positive polarity. So, it is more of a it's more of a charge interaction than nucleophilic attack. Nucleophilic attack is all about orbital overlap. So, if you look at this carbon, the carbon of the ester, this carbon has quite high positive polarity, because carbonyl group is there which pulls away the electron towards itself and creates lot of negative charge. So, therefore, this negative, so the reaction is more of a kinetic attack. So, negative attacks maximum positive charge possible. So, of course, it attacks here, and then what happens? Then the low electron comes up, electron comes down. So, it is a shortcut which you can show in 2 steps, or you can show in 1 step, and this OET minus leaves, and therefore you get this product. So, this is A. Now, same thing when sulfur is there, sulfur is highly stabilized. Okay, so it's all about the big lobe is there, and with lot of negative charge which is delocalized. So, it is not attack, won't be your charge interaction, it will be orbital interaction. So, it's more of thermodynamics which rules. So, this negative will go and attack here, because you understand this is 1,4 alpha beta unsaturated ketone. So, attack will be 1,4 addition. So, these lobes are basically small, because this carbon is attached to oxygen, oxygen pulls the electron to itself. So, of course, lobe is smaller, whereas it is more of a alkene. So, alkene lobes are much larger in size, because next to it electronegative atom oxygen is not here, and therefore attack occurs on this carbon, and then this moves up and this goes up. Then once it gets down, it goes and attacks the proton, right, and therefore this is 1,4 addition. So, this is B. So, answer is option D. Answer is option D. So, I will go slowly, you please read whole thing, whatever I said is written here, you can pause it also. Next question. The major product A and B formed in the following reaction are. So, first reaction in the first step, you are adding UV light in presence of I2 and oxygen. So, when you see alkene and you see UV, you generally think it will be photoisomerization, but it is not photoisomerization, it is basically you are adding iodine and oxygen. So, it is basically catalyzed equilibration reaction. So, what happens is iodine is there, in presence of light it breaks, because iodine is very large in size. So, when two iodines are there, this bond is very weak. So, little bit also light, it immediately breaks up into two iodine radical. So, now this iodine radical interacts with this with the double bond, through radical mechanism, and you get single bond character and the electron is here. Now this can rotate. So this was trans, now it can rotate and come to cis. So yeah, what I have shown here is this I again comes out to form iodine again, and it rotates and you get cis. So again, see, trans is much more stable than cis. So again, after all this equilibration, still trans will be more, but at least some amount of cis is formed, which would not have been possible simply because you cannot isomerize double bond simply because it gets single bond character. It is able to rotate. So that gives a reaction possibility. What happens? This trans becomes cis. Once cis is formed, it can undergo electrocyclic cyclization reaction. Yeah, it undergoes electrocyclic cyclization reaction. Now this is nothing, it is electron comes here, this goes here, and this comes and attacks here. So it is electrocyclic reaction. It is six membered ring it forms, and you get this product, right? So this will be 4n plus 2 because 6 pi electrons involved and h nu. So 4n h nu is this, so 4n plus 2 h nu will be con, but they are not asking stereochemistry, so we don't need to bother. But if you want to know, you should know that this will undergo through the con rotation. Next is important. Now we are adding BCl3. Now BCl3 is a Lewis acid, so it will go and coordinate. Now we have to understand it acts as electrophile. Which electrons will go and attack first, right? So oxygen lone pair on the carbonyl is more nucleophilic than oxygen on lone pair on the oxygen with single bond, because it's a pi character which increases the electron density. Okay, so this goes and attacks here, this BCl leaves, and this goes and forms. So now you get a chelated ring system. Next what happens? Next the single OMe goes and attacks BCl3, and now what happens? Because it is chelated system, it is much more stable. So it's not easy to remove this Me because it is part of stabilized ring. But this Cl minus, see, boron is having negative charge. So once boron is having negative charge, all its sigma bond becomes nucleophilic in nature. So this BCl bond is nucleophilic in nature, and therefore this Cl comes out, this sigma bond becomes nucleophilic. It goes and attacks this Me, and this comes out, and you get like this. And once you do workup, everything comes back. You are having Me here, sorry, OH here, OMe here, and your compound. Thus the answer is option A, right? Moving on to the next question. The question says the major product formed in the following reaction is. So you are having a lot of carbonyl groups and they are not conjugated. So you react it with sodium ethoxide, which is a powerful base. So what will sodium ethoxide do? Sodium ethoxide, it can pick up any proton, but primary carbanion is more stable than your secondary. So rather than picking up proton from somewhere here or in between, it will pick up proton from the side. And apart from that, we have to know that once it is formed, it undergoes aldol condensation. Now aldol condensation, it is preferred over 6 membered ring than 7 membered ring than 5 membered ring. Okay, so we have to count and see that which aldol condensation, basically water is lost. So you see here H2O will be lost. So look for 7 membered ring where oxygen and carbon having 2 hydrogens are sorry, we are looking at 6 membered ring. They are 6 bonds apart. So this is 1, 2, 3, 4, 5 and 6. So this carbonyl can be lost, and then you get a 6 membered ring. So that's what happens. Basically this is lost and you're getting this alkene, right? Mechanism is very simple. I don't think I need to do also, but it's okay, I'll do it. You remove the proton, you get negative charge which is stabilized, and that negative charge goes and attacks on this carbon. This comes up, and then ethanol, it will pick up proton. It's not easy to remove. Ethanol, you cannot OH minus is bad leaving group. That's for OET minus cannot directly attack here so that this OH leaves. That's not possible. Okay, but if you put negative charge next to that OH, then the orbitals overlap so that this OH minus leaves and you get a pi bond, and therefore you get this reaction. Thus the answer is option number B. Next question. In the given transformation, what is intermediate A and what is the major product B? So you are having benzaldehyde 2 equivalents. you are having this molecule N2CHO2EtCuCl. Okay, so this was interesting question. Basically, this is what is your N2CHCOOET. So, um, this is a precursor for carbene. If you look into Jerry March, it talks about how carbenes are formed. This is one of the way diazo carbonyl compound. So, this N2, see nitrogen valency, you just look into it. So, CO, it is very clear, then CH, N2. So, double bond and double bond, and that is how it is generally. So, this nitrogen has negative charge, this has positive charge, because nitrogen valency 3. Now, this comes here and this will come here, you get a negative charge, which I am showing here as negative like this, and then this comes, it comes to this and this leaves, so that it becomes neutral and it becomes carbene. So, carbene is a species where carbon is neutral, but its octet is not complete. How many electrons are there? 1, 2, 3, 4 and 5 and 6. So, its octet is not complete, it has only 6 electrons, so it is electrophilic in nature. Now, what do we have? We have benzaldehyde. So, benzaldehyde will go and attack on this. Benzaldehyde lone pair of the oxygen will go and attack here, you get this, and this comes up, you get like this. Now this will undergo what is so this was your A, okay, this was the intermediate A. Now this intermediate A undergoes 1,3 dipolar cycloaddition with your benzaldehyde. So you can see here 1, 2, 3. So though positive charge is here, but oxygen is electronegative, it pulls most of the electron cloud towards itself pi bond. So actual positive polarities on carbon, oxygen is almost neutral, okay. So polarities at carbon number 1 and at carbon number 3. So this negative goes and attacks here, this goes and attacks position 3, and you are getting 1,3 dipolar interaction. So this is your answer. Last question for this video. The major product formed in the following reaction is. This is very interesting question, quite tough also. So you are having alpha beta unsaturated ketone and you are having this compound. You are reacting it in presence of palladium catalyst and phosphorus triisopropoxide. So one thing we have to understand, for reaction right now it is at Pd2 plus, and palladium undergoes catalysis reaction in Pd0 form, right. So first thing what will happen, another thing what we have to remember is phosphorus here is +3 oxidation state, never happy with +3, it always want to become +5, that too phosphorus badly wants to become P double bond O, okay, or rather it is a ylide actually, P plus and O minus, and you are having all isopropoxide. So this will guide your first step. So first step what happens, this phosphorus goes and attacks on this palladium and one of the OAC leaves, So what happened, it got one electron and it lost one pair of electron. It got one pair of electron, lost one pair of electrons, so it is still +2 oxidation state. And then what happens? Then OAC minus leaves. I'm so sorry. Yeah, this one attacks and this leaves, so still it is +2. Yeah. Then next step what happens? Another molecule of phosphorus goes and attacks. Another molecule of phosphorus goes and attack O. IPR3. So now what happens, this 3 I am not doing, okay. So what happens now, phosphorus when it goes and attacks here, now Pd from +2 it becomes Pd0 because it got 2 electrons, right, and then you get this kind of species, and then OAC will go and attack on phosphorus, you get like this. Remember, always phosphorus will try to become P double bond O. Therefore, this acetate goes and attacks here, this comes here, this goes here, and you get this. Now, this is your catalyst where Pd is 0, right. Now, what is very important is Pd0 catalyzes cycloaddition reaction. One of the most successful in this is use of trimethylene methane 3+2 cycloaddition. So, trimethylene methane, it looks like this. Where am I? Yeah, here, something like this, okay. So, to make this is a good precursor. So, what happens? This species is very, very interesting. This is electrophilic also and nucleophilic also in presence of palladium. So what happens when palladium pumps electron, you get a negative charge on this bond. Basically the acetate leaves and you are having palladium is electropositive because some metal, so this will have positive and carbon will have negative. Okay, and apart from that, um, yeah, so this becomes electropositive species because you are having positive polarity because of palladium, and this gets negative polarity because silicon has a great affinity for oxygen. Why? Because O minus rather, because silicon is more electropositive than carbon, so it gives away electron. So lot of positive polarity. Very hard base it is, hard acid it is. So acetate can go and attack here. So let me just show this step by step. I am so sorry, I might have confused you all. So basically first palladium goes and attacks here, this comes and this leaves. So what happens? You are having positive polarity. That positive is being shared between this carbon and this carbon, right? So this is a electrophilic species. It loves electron because it has positive polarity. Apart from that, what happens is acetate goes and attacks silicon because just now I explained how oxygen has great affinity for silicon. This comes up and you get negative charge. So this is spread around, so you will see that positive, you can say here it is positive or here it is positive, both it means same. So either way the other part will get double bond if I try to localize that positive charge. So I can say it is something like this species. So now this is 1,3 dipolar species, positive and negative. Now this will happily undergo interaction. This product is formed. I will show you how it is formed. So basically you are having negative and you are having positive here. So negative goes and attacks here, this comes up and this comes down and this goes and attacks on the terminal because we saw positive charge is either on this end or this end. So it attacks on this and therefore you get species. Now it is a cycloaddition reaction. It all occurs in concentrated step 1 mechanism and therefore the product form is cis product. Both CH3 and hydrogen are one side, either towards the viewer or away from the viewer, and this will go up in the get away in the workup, and therefore answer is option A, right? So that's it for today's video. Thank you very much.